Good afternoon. Hope everybody's doing well today. This is South Carolina Rural Water Association, and the purpose of this demonstration is to show proper maintenance and fire flow of your system fire hydrants. So the first thing we're going to do is we're going to talk about some of the parts of the fire hydrant, how the hydrant functions, and then we're going to go out in the field and we'll put that information to use as we fire flow our hydrant in the field. Okay, so when we're talking about a fire hydrant, the basics of it is a main valve at the bottom, which is what isolates the hydrant flow from the distribution system, and then an operating portion of the hydrant that's actually designed to manipulate that valve down at the bottom. So the important thing with hydrant maintenance is you want to make sure you keep the operating portion of the hydrant, which is the top end, in good condition, but you also don't want to neglect the main valve down at the bottom. Now, even though there's only basically one moving part at the bottom of the hydrant, the importance of that part being able to move back and forth fluidly is extremely critical to the proper operation of the hydrant, as well as to making sure that the hydrant stays in service as long as absolutely possible. So the important thing about the bottom of the hydrant is the weep holes. So there are basically two different types or styles of fire hydrant that are commonly seen out in the distribution system. One is a wet barrel hydrant, and in a wet barrel hydrant configuration, the entire barrel of the hydrant stays full of water all the time. And then there's what we call a dry barrel hydrant. And after the function of the hydrant is complete and the hydrant is closed back off, the water will actually drain out of the barrel and out into the ground surrounding the hydrant. And it does that through weep holes that are located in the side of the main valve foot on the bottom of the hydrant. Now, it's important to keep those weep holes clear, and the way we do that is by operating the hydrant in such a way that we open the hydrant up completely. And what that allows is for guides on the side of the main valve to actually force water from the distribution system through the weep holes, and it cleanses them out, purges out any grit or soil that's collected there, and it keeps the weep holes free to operate. And the way that you do that is by always making sure that you open the hydrant completely. If you don't open the hydrant completely, what can happen is the weep holes will stay open and can actually flood the area around the hydrant while you're trying to do your inspection and do your work. So very important when we're operating hydrants to make sure that you operate the hydrant all the way open so that you allow the purging action to take place on the weep holes, keep them clear, but then also close them back off after the full opening process is completed. Okay, so now we're going to talk about the operating portion of the fire hydrant. And basically what this does is allow an operator to transmit torque through the operating rod of the hydrant down to the main valve on the bottom of the hydrant, which allows it to open and allow flow to come through the hydrant. The important thing about this mechanism here is it requires lubrication periodically, and typically that needs to be done every year. And what's happening here is, you can see we have a bonnet up here up top, but within the middle of the hydrant, and this is typical of most brands, even though they have somewhat different configurations, you have what's called an oil reservoir. The oil reservoir actually keeps the operating rod constantly bathed in oil and thereby allowing everything to stay lubricated and operate well. The important thing to note inside the upper portion of the operating section of the hydrant is O-rings. Now, different manufacturers have different quantities of O-rings. In this configuration here, there's a gasket, and then there are 4 O-rings that isolate the operating rod from the oil reservoir or the iron portion of the hydrant. This can vary from manufacturer to manufacturer, so it's important that you get familiar with the diagram cutout of your particular hydrants that are located in your distribution system so that you know how many and what size O-rings you'll need for preventative maintenance. So that's going to sum up our nomenclature portion of the hydrant class, and we'll now move out to the field and we'll fire flow a hydrant in the field. Okay, so here we are out in the field. We've gone over our hydrant nomenclature, and now we're going to actually go through the field practice of maintaining our fire hydrant and also doing a fire flow on the hydrant. Now keep in mind that when we're talking about flushing a fire hydrant, we're really achieving two different objectives there. And one is to clean our water mains and create a scouring action that will cut down on the buildup on the inside of the water main. The other thing we're trying to do periodically is establish what the fire flow is for the hydrant. And so that's what we're going to be talking about today. And also maintaining the fire hydrant. Now, as far as how that goes, the interval that you would use to decide when it's time to do that, the main thing is that it's done per your SOP. So if your SOP says that your water system maintains every hydrant every year, then that's what DHEC is going to be looking for when they come for your sanitary survey. They're looking for you to be in compliance with your standards as a water system. So one way to do that is to oil and lubricate every hydrant and just give it a visual inspection, and then flow the next hydrant in line. And you can switch off each year so that every year you're maintaining every hydrant, but you're flowing every hydrant every other year, if that makes any sense. So what we're going to talk about now first, before we actually hook the equipment up to a hydrant and talk about the procedure for flowing the hydrant, is we're going to talk about some of the tools that we use to do that. So some of the things you're going to have that are basic tools necessary for this procedure are a pitot gauge or some sort of device to measure the flow or the pressure coming out of the outlet nozzle of the hydrant. And this is a typical clip-on pitot gauge that you can attach to the lip of the 2.5-inch nozzle and actually measure the gallons or pressure out of the hydrant. And most new gauges today will do both. They actually make the conversion from pressure, and that calculation is done on the gauge. And so it's basically reading the pressure, then converting that on the gauge to the flow in gallons per minute. If you don't have a gauge that gives you the flow on the gauge itself, then most test kits come with a sheet that will do a conversion from the flow pressure into the flow quantity in gallons. Okay. The other thing you want to have is it's a directional nozzle that will allow you to control where the water is directed out of the hydrant. A common mistake that I see when I see folks flushing hydrants is they either flush them straight out of the hydrant, which tends to tear up any sod or shrubbery that's beside the hydrant. And then I also see this tool used improperly sometimes. If you have the ability to direct the flow of your water, make sure when you're flowing the hydrant that you don't flow the water out into traffic. That just creates another hazard, and we're trying to do this operation as safely as we possibly can. But the nice thing about having a directional nozzle that's set up like this one is not only do you have the gauge built into the nozzle, so that cuts down on the need for extra excessive tools, but this also has a handy catch basket on the end of the nozzle itself. And this is useful for seeing what's actually in your mains. Any bits of iron or wood, scraps, etc. that might be in your water mains will be trapped in this cage, and you can inspect it after you get done flushing the hydrant. So a lot of adaptability with this tool, and here momentarily we'll show you how we set that up. The other thing you're going to want to have is a tool to be able to open up the oil reservoir on the hydrant, which is typically on the cap of the hydrant. Sometimes it'll be an Allen wrench, like in this example right here. It's also handy to have a double bit screwdriver, because you might need a Phillips head bit or a straight bit. But make sure you're familiar with the hydrants in your system so that you're prepared with whichever size Allen screw or Allen tool that you need. I have this one set up for Mueller hydrants. I believe this is an 11 millimeter, quarter-inch Allen tool. So just make sure you're familiar with the different types of oil caps that you have. In a minute, we'll show you the procedure for getting those open. And just make sure that you can get the cap out and be able to put oil into the hydrant. All right, the other thing we're going to use here, and you can see 3 different examples that I have. These are all pressure gauges for measuring the residual and static pressure at your offset hydrant. That's going to be the next hydrant in line. And I have different styles here, but the main thing you want to have is the ability to turn the flow of water on and off through the gauge. And the reason that's important is when you first open up the hydrant, you're going to want to have this valve open and bleed all the air out of the hydrant before you start the procedure. You want to have a full bore of water inside the hydrant at your residual pressure station, and this allows you to do that. So make sure that your gauge is not just a gauge and a cap, okay? The other thing you need is 2 hydrant wrenches. If you're using the single man technique or the single hydrant fire flow technique, you of course only need 1 wrench, but the preferred method for testing your static and residual pressure on your hydrant is to use 2 hydrants. So you want to have 2 hydrant wrenches available for that. And then it's always nice to have rags handy. If you think this is not a dirty job, I can tell you that everything on this rag came from hydrant maintenance. So hydrants do tend to get dirty. There's oftentimes a lot of residual grease and material and whatnot. So you want to be able to clean up afterwards and wipe up anything. And it's also good to have a good pair of task gloves. It's just good for handling materials, and it makes the work a lot easier. All right, so now we're going to go ahead and move over here to the hydrant, and we'll actually go through the procedure of demonstrating the proper technique for fire flow on the hydrant. All right, so here we are. We're set up at our demonstration hydrant, and again, we're not going to live flow this hydrant because it doesn't belong to us. But the main thing when you're getting to the exercise of starting this procedure is, if you haven't done so, make sure that you build a catalog record on your hydrant maintenance log. And I really recommend having a single sheet dedicated to each hydrant, or at least a half sheet. And what you can do with that sheet is you're gonna write down everything that's important about the hydrant. You're gonna want to know whether it's a 5 1/4 inch barrel or a 4 1/4 inch barrel, and that information on this hydrant is stamped up on the edge of the bonnet. The other thing you're going to want to make a note of is obviously the manufacturer of the hydrant. On this hydrant, that's stamped onto the back, and it's actually cast into the barrel of the hydrant. And you're going to want to note what year the hydrant was made. These are all critical items if you're trying to order spare parts. It prevents you from having to look that information up in the field. The other thing you want to make a note of on the paper is which direction the hydrant opens. And in this case, this hydrant is actually a reverse opening hydrant. It actually opens by turning the wrench counterclockwise. So that's not typical, but varying systems, it just depends on how the system was begun, and usually if a system began one way, they would normally stick with it. So the other thing we're going to do after we've written down all the information, the other key item you want to have is the diameter of the main that serves the hydrant. Of course, that always ought to be greater than 6 inches. And after you've noted all that information, then we're ready to go ahead and fire flow the hydrant. And so the important thing to do now is to go around to all of our caps, the 2 2.5 inch nozzles and the 5.5 inch nozzle, and make sure that everything is tightened down. Because obviously you can't get a good pressure reading if you've got water escaping from your hydrant. So now that we've done that, we're ready to go ahead and hook up our flow nozzle. And so we're gonna take the cap off on this side of the hydrant. And we've analyzed our traffic pattern, and we've determined that this is the best direction to send the water, so that it's a minimum of disruption to traffic and a minimum disruption to landscape and other appurtenances that are beside the hydrant. All right, so now that we've attached the flow nozzle, we've got the nozzle directed in the direction we want it to go. We've got our gauge set in a position to where we can see it and be able to view the pressure and the flow on the hydrant. So now what we would do is go ahead and open the hydrant up. And if we were using a 1 hydrant technique, it's important at this point to go ahead and note the flow pressure on the gauge once we start to flow the hydrant. And after it's stabilized is when you want to do that. If we were using the 2 hydrant method, which is the preferred method, you would have another man at the other hydrant who would have already opened up the hydrant after attaching one of the pressure gauges to it. And he's going to be reading the static pressure on the system prior to the hydrant being flowed. And then at the same time that we open up this hydrant, he's going to read the pressure after it's stabilized on that gauge and be able to get what's called the flow pressure. So you have a residual pressure, it's also called a flow pressure, and this pressure is the pressure in the distribution system representative of the hydrant, this hydrant actually being flowed. And then we have a static pressure, and that pressure is the system pressure with no fire flow happening at all. So he's going to make a note of those two pressures on his form, and what we're going to be looking for down here is the actual number of gallons being flowed, okay? So we're going to open up the hydrant, and the critical thing here is, what a mistake that's commonly made is to only open up the hydrant part of the way. And if you remember from us looking at the nomenclature on the hydrant, I described why that's not a good thing. You always want to make sure you open these hydrants up all the way. That's when you want to be looking at your flow. And then at the same time, you also want to, when you turn the hydrant back off, only turn it off enough to get it to stop flowing. And newer hydrants are going to be very, very good about that. Older hydrants are going to tend to want to be knuckled down on. And that's just because that gasket on the main valve, which we saw on our demonstration hydrant, that gasket has had a time to be pressed into the actual foot of the main valve, and it's memorized that position. And so hydrants like that tend to leak more. So only apply enough torque to the operating nut here at the top of the hydrant to actually turn the hydrant off, and no more. All right, so now we flowed the hydrant, we're ready to take everything back off, and when we talked about our weep holes on our demonstration hydrant, it's at this point that you should know whether those weep holes are working or not. Once you turn the hydrant off, you should actually hear the water being drawn back down through the barrel. And if you're not hearing that, and then if you take the nozzle off and you can actually see water still spilling out, or you can see a pool of water inside, that means your weep holes are not opened up and they're not functioning properly. Okay, so what we've done here is we've installed our pressure gauge, and this would be in the two hydrant technique, which is the preferred method for fire flowing hydrants. This would be the hydrant that's actually next in line to the hydrant that we're fire flowing. So you're going to have a man at this station who has the ability to turn the hydrant on, open it all the way up with the pressure gauge in place, which will then give us a static pressure. He's going to be standing by, and when the next man down the line flows the hydrant, he's going to then record the flow pressure that's indicated on the gauge. Now remember, when you first took this gauge up to the hydrant, before you open the hydrant up, be sure and open up the petcock down here so that all the water can escape and be forced up the barrel, and you don't have any air trapped in the barrel of the hydrant. Once that's flowing nice and smoothly and cleanly, you can go ahead and turn that petcock off, and you're pretty much ready at that point to go ahead and record the static pressure in the distribution system. After you're done, you can just turn the hydrant off and remove the gauge and move on to the next one. A nice little trick is, if you know this is going to be the next flow hydrant, make sure you leave the cap off for your buddy as he comes down. That way he doesn't have to be undoing the nozzle to attach his flow nozzle to this hydrant. Because again, this is a step process. Okay, so now that we've flown our fire hydrant, now's the time to take a look at any maintenance that might be needed on the hydrant that it might require. And this is where you're just going to take notes. You want to note your caps to make sure you're checking your caps for the gaskets being properly in place. A leaky fire hydrant is sort of a pain, so it's always better to have good quality gaskets inside the caps. You also want to note the inclusion or lack of safety chains on the hydrant caps. You know, a lot of systems have gotten away from this, but if you have safety chains and caps, you want to note the integrity of that at the time of the inspection. And then really, other than that, you're going to want to oil the hydrant. Now, during the process of flowing the hydrant, you might have noticed when you opened up the hydrant that you actually had water escaping from the top of the hydrant. Whether it was around the edge of the bonnet, it might have been around the edge of the operating nut, and it might even have been around the cap that's in the top of the operating nut. Now, you want to note that, because that means that you have gaskets or O-rings. Remember when we looked at the nomenclature of the hydrant, those gaskets and O-rings can fail over time. And the way you're going to see that is you're going to notice water coming out around the top of the hydrant, okay? So you want to make a note of that. set that hydrant up for routine maintenance. And then at the same time, you want to go ahead and put some oil in the hydrant. This should be done yearly. That's why I talked about the process of inspection. No matter whether you flow the hydrant every year, you're at least checking the oil in the reservoir each year. So to do that, you're going to undo the cap in the top of the operating nut here. So sometimes that might be a flathead screwdriver, it could be a Phillips head screwdriver, but it could also be an Allen key such as this nut right here. So all you're going to do is undo the Allen cap, and using a squirt bottle, you're going to administer oil into the hydrant until oil comes out of the top of the nut here. Then you're going to replace the screw, and that should be good to go. And again, like we talked about on the hydrant, what that oil does is it keeps the operating rod in a sort of constant bath of oil and prevents it from seizing up and causing poor operation. If you happen to be dealing with an older hydrant, it's quite possible you could have a hydrant that requires grease instead of oil. It's very important that you do not put oil in a grease hydrant. And usually the way you can tell is the configuration on the cap of the hydrant, whether it be on the side of the operating nut or the operating nut shroud. You'll have actually two screw holes. So a lot of times you'll have one in the center of the top of the nut, but then you'll have one sort of offset over here to the side. And what that is that's an escape hole for the grease. So you'll actually administer the grease through the top cap, and you'll basically keep pumping the gun until you see grease come out of the side screw on the side. All right, now it's very important to note you cannot just put any normal lubricant in these hydrants. My recommendation, all the manufacturers have their own specific blend of oil that's basically a food grade mineral oil that you can use for the hydrants. My recommendation is go to your local pharmacist and have him order you a half gallon or a gallon size of mineral oil, and you can use that for the oil in your hydrants. If you have grease, it's very important that you use a Hobart food grade grease that's NSF approved. It's going to be a white grease. It's normally sold through food equipment companies. You can probably also get it on Amazon. But you do not want to put standard petroleum grease or petroleum oils in these fire hydrants, because that can give you an adverse effect on public health.